So in 3b-4, we're continuing to work with some word problems. The types we're working with will be distance word problems. We have money word problems. So we have our distance word problems and we have our money word problems. So we'll start with the distance word problems and then we'll work on the money ones. So the first distance word problem, there's a couple things we need to just kind of think about when we're doing distance word problems. Sometimes we have distance plus another distance, so distance 1 and distance 2, and that has to give me like 1,200 kilometers or whatever they tell me. So in some of them, we add the distances together. In some of the distance problems, they are actually equal to each other. So we have two types. We have type 1 and we have type 2, and we have to decide which type they are. For example, if in this first example here, we have the top speed of an elephant is 666 meters per minute. The top speed of a zebra is 1,066 meters per minute. If an elephant and a zebra were running away from each other, how long would it take them to reach this distance? So what they're asking for is, what is the distance of the elephant plus the distance of the zebra, and that would have to add up to, in this situation, 3464. They're actually going away from each other. The total distance is 3464, so we have to add the distances together to get 3464, and now it just becomes a rate problem. So what we do is we'll let t equal time, and then we're going to say the elephant is traveling it at 666 t, because we don't know what the time is. I'm actually going to pause this for a second to make it a little bit, clean it up a bit. 1 second. So that's just a little bit cleaner. So once again, we have two different types of problems. We have a type 1 problem where we add the distances together, and a type 2 problem where the distances are actually equal to each other. The first one we have is a type 1 problem where we add the distances because we're trying to find a total distance of 343. So we're going to let t be the time traveled, because we're looking for how long does it take, which is time. And then we can start writing our equation. The elephant travels, so we have the speed of the elephant plus the speed of the zebra has to give me 3,464. The speed of the elephant is 666 meters per minute, which we'll say is t because we don't know what time is. We're going to add to it the speed of the zebra per minute, which we don't know. Now what you've noticed is t and t are the same. They're the same variable. If they were different, one would be t, one could be a different variable, but we want to know how long it is, and it's the same amount of time, so the variable will be the same. So the key here is we want to know how long will it take. Well, that's only one variable, that's time. It's not different times, it's not minus 1 hour. So just be cautious when you're dealing with time questions that you're looking for. What are you looking for? And in this situation, you're looking for one variable. So the speed is 666 per time plus 1,066 per time, which we don't know what it is yet, and this has to give me how far they are apart. I'll do my distributive property. I get 666t plus 1,066t. I will add my like terms, and I get 1,732t. To solve for t, I'll divide by the coefficient, and 3,464 divided by 1,732 is 2. So it takes 2 minutes for them to get that far apart. So those can be a little bit confusing, so let's try another one. I'll erase some of this data here. Again, pause it whenever you feel you need to. I'm going to leave the different types of problems on because that's always important. I'm going to move this up so we can see the next problem. And we have, in this situation, we have a car leaves Montreal for Toronto at a distance of 540 kilometers at 11 o'clock, traveling 85 kilometers per hour. At the same time, another car leaves Toronto for Montreal, leaving at 95 kilometers an hour. What time will it be when the two cars meet? So if we look at this kind of question, we have Montreal, we have Toronto, we have car A leaving at 85 kilometers per hour. We have car B leaving at 95 kilometers per hour, and they want to know at what time do they meet. So once again, we have two types of word problems. We have a distance plus distance gives us a grand distance. That's up here. Sorry, you can't really see it, but it's there. We have distance equals distance. In this scenario, the distance here does not equal the distance there. It just doesn't make sense. They're leaving at the same time. They're traveling the same amount of time. One's traveling faster. So the distances do not equal each other. But it does make sense that distance 1, which is this car, and distance 2, which is this car, they will travel a total distance of 540. So this is almost exactly like the last question. So we have car 1 plus car 2. When they add them up, it has to add up to 540. So we do the speeds again. 85 kilometers per time plus 95 kilometers per time equals 540. And 85 plus 95 is 180t. Gives me 540. I'll use algebra. And 540 divided by 180 is 3. So the total time for them to meet is 3 hours. So car A travels 3 hours, car B travels 3 hours, and they meet here. If they ask how far did car A travel, then if they didn't ask this, but if they wanted to, I could substitute back into there, and 85 times 3 would give me how far that car traveled. If I want to know how far B traveled, I can go 95 times 3 to get that distance if they asked me to, but they didn't. But in case they do, that's how you would solve those kind of questions. So I'm going to clean this up and we'll try another question. So questions 3 and 4 are the exact same type. You just have to make sure, is it a total distance problem when you're adding them, or are they actually equal to each other? We're going to actually look at number 3 because it's a bit different. Number 4 is exactly like number 1 and 2, but number 3 is a bit different, so we're going to take a look at that one. That can be a bit challenging. Move some things up. Okay. Number 3 is one of those distance problem where distance equals distance. So we have two planes. We have a plane leaving London, traveling at 800 kilometers an hour. And it leaves at this time. That doesn't really matter. What does matter is this other plane leaves an hour later. That matters. The other plane, okay, and it flies at 1400 kilometers per hour, and they want to know when do they meet in the air. So when will plane A be passed by plane B? The only difference in this problem is that they have different speeds, but they're actually leaving an hour later. So if the distances would be exactly the same, it doesn't really matter what the distance is. they are going to be the same because eventually the Concorde passes the Boeing. So they pass the Boeing, the distances will be the same. What is the key of this whole problem is time. If we're going to let t be the time, then if this was 5 hours, this would be 4 hours because it left an hour later. If this one was 6 hours, this would be 5 hours. If this was 7 hours, this would be 6 hours. It's an hour later. So the good thing about that is if t is time, and we don't know what the time is, t minus 1 will be the time of this guy. So we have t being the first one, that's time, and t minus 1 being the time of the plane that left 1 hour later. Be careful when you're dealing with 20 minutes because it wouldn't be minus 20, it would be like minus a third because you're dealing with hours. So if they're not full hours, be aware of that, just be cautious. So we can write this out. We're going to have distance 1 equals distance 2 because they're the same distance. Distance 1 is 800 kilometers per time. We don't know how long it is. Distance 2 is 1400 kilometers per time, but 1 hour later. So that's the key here. 1 hour later is the key. I will use distributive property to get 800t equals 1400 t minus 1400. Remember distributive property. I will use my algebra skills. I will minus 1400 on this side and minus 1400 on this side. T. This will cancel. I'm left with minus 600 t, which equals negative 1400. I then divide by 600, negative on both sides, and this equals negative here, and a negative will be a positive, which has to be because it's time. And this gives me 2 hours and 33 minutes, which is, and again, I'm sorry that this is so messy, but this will be 2 hours and a third, because 0.3 of 3 is a third, so about 2 hours and 20 minutes. So it will take 2 hours and 20 minutes before the Concorde overtakes the Boeing. Remember, distance is equal to distance type of problem. Distance equal distance. Now the only thing that changes is your time. Time, and then time minus 1 hour, or time minus 2 hours. Depends on what the question gives you. So just be cautious of what they give you. So I'm going to clean this up now. So now we'll do the money problems. And remember, the money problems are just looking for the one variable. So usually you have, like for example, the first one, you have dimes and quarters. They have to relate. There's going to be two equations you're going to write. You're going to write an equation for dimes and quarters, how many coins you have. You're going to write an equation for dimes and quarters, how much it's worth. So let's start that first. Dimes plus quarters will have to add up to $13. I like leaving it as 1,300 because I like dealing with pennies. I don't really want to deal with decimals if I don't have to. I like then going and saying, well, what's a dime worth? A dime is worth 10 cents. A quarter is worth 25 cents. And it will all add up to 1,300. This is your value. This is what it's worth. Now, right now, we have quarters and dimes. And we can't have that. We have to have one variable. So we look at this equation. And sorry, we don't look at that equation. We make a next one, which is 70. So now we know that dimes plus quarters adds up to 70. It says there's dimes and quarters. There are 70 quarters. Or sorry, there are 70 coins. So we look at this equation. And now I can easily minus q on both sides, which I don't know what it is yet. That's not even relevant. D will be equal to 70 minus q. Do not mix up the order. It's not q minus 70. It is 70 minus q. Now we know what D is worth. we can go back to this equation, and instead of using D, we use D equals 70 minus Q. So now 10 equals 70 minus Q plus 25Q, and that has to give me 1300. So from here we'll use our distributive property to get 700 minus 10Q plus 25Q equals 1300. We combine our like terms, we get 700 minus 15Q equals 1300. Using algebra skills, I'm going to move this here. I'll be left with minus my mistake again. I'm not thinking correctly today. This is going to be a positive here. So for those who caught it, great job. I did not. So there we go. This will be a plus 15Q. And this will equal 600. I'll divide by 15. Q will be equal to 40. And if I need to, if Q equaled 40, then dime would have to be 30. So dimes is equal to 30. So you have 70 coins, quarters and dimes, and they will add up to $13. All these types of questions are exactly the same. Here, 4 more nickels than dimes. Well, then D is equal to D. Nickels is equal to D plus 4. So now you have your same variables, just like we need up here. Every time it's going to be the same. You want to make sure that you can have only one variable in your equation. In number 7, you're going to have D is equal to dimes, and N is equal to 4 times as many nickels as dimes. So whatever dimes is, we times it by 4. Here are my two variables, D and 4D. Number 6, you're going to have 3 different coins, loonies, quarters, and dimes. They all relate somehow, and your job is to figure out how do dimes and quarters and nickels all relate, dimes, quarters, and loonies, all relate to each other, so that when you write your equation that looks like this, your value statement, you can have 3 different statements, but all with the same variable, and that's the challenge of these types of questions. Hopefully that helped. If I can't.